argument as to why the Earth was not spinning around was that people thought you'd be flung off into space if the Earth was spinning around. Well, here's a picture of the Earth. Here's somebody standing on the equator, and they're spinning around on the planet Earth. We know that the radius of the Earth is 6.378 times 10 to the 6th meters. We're going to just assume the mass of the person is 80 kilograms. And the last piece of information that you would need to solve this problem, although it's not given in the problem, is how long does it take to go around one time? How long does it take to make one revolution on this particular circle? Well, the Earth spins around once in 24 hours. So this little person would go all the way around the globe, basically, once in 24 hours, or when we convert to seconds, that's 86,400 seconds. Last piece of information you need in order to solve this particular problem. So the first thing that we are trying to find is, hey, what would be the centripetal force that is necessary to hold someone onto the planet as they're spinning around? Now we know that force of gravity is the centripetal force, but we're just going to solve for basically the centripetal force. So what is that? I have to pick my equation. I have an R, I have an M, I have a T. So I'm going to choose the M, 4 pi squared R, over T squared version of centripetal force. And when I plug in my numbers, I have 80 kilograms times 4 pi squared. The R is the 6.378 times 10 to the 6th meters, all over 86,400 seconds squared. And if you plug all that into your calculator, you find that it only takes 2.7 newtons of force to hold an 80 kilogram, or about 175, 180 pound person onto the planet Earth. Well, what's the force of gravity acting on someone on Earth who happens to have a mass of 80 kilograms? That's the next part of the question. Force of gravity is mg. So that's simply 80 kilograms times 9.8 meters per second squared. So gravity is holding this person's feet to the ground with 784 newtons of force. So there's definitely a lot more gravity to spare than what is necessary to keep you on the planet, since the planet's spinning around.